Hey, folks, welcome to our first episode of Hot Data. I'm your host, Josh Robinson. Today, I am joined by Krassi. We're here to talk about the Honeynet Project. Krassi, how are you?
I'm good. How are you, Josh?
Pretty good. As I'm learning about the Honeynet Project and Hydrolix's role in that uh, particular space, one of the things that I was really interested in is like what we're doing for the project, how we're contributing, and then also our stance on open source and how we contribute to that. So could you walk us through what you've done, things that you've noticed, and anything like that?
Yeah, absolutely. And that's actually multiple questions here that you asked me. So I'll probably start with our our stance on open source and in general community projects. I would actually go more in the community project. So, I cannot speak directly for the company, but I can tell you that Marty, the CEO, has been very, very supportive of us supporting the community, and working with the Honeynet project is one of those initiatives, but also we have contributed in other places. We do a lot of work for NANO, which is the North American Network Operators Group. I'm actually on the program committee there, and I'm allotted the time to work on that. And in general, we have been very, very supportive of those communities. But what we wanted to do with the Honeynet project in particular is we wanted to facilitate their work. Now, I have another hat where I have been involved with the Honeynet project for probably 15 years now. And one of the challenges the Honeynet project had was that there is not a centralized place for data. And just to make sure that it's not misunderstood, so I was running the Bay Area chapter of the Honeynet project, and I'm right now looking at opening a chapter at Purdue University. So I am not on the board of the Honeynet project, so I just want to make sure that this is kind of clear. But having said that, I have a lot of visibility into the challenges and how different chapters have had a challenge of sharing data, working collaboratively. So, this is why I came up with the idea is like, hey, we have the perfect solution for that. And not only it's the perfect solution, but it is also fairly inexpensive. So we may even sponsor the storage and retention of data. And this is not going to break the bank just because the nature of our technology is such that we allow people to store information in a highly compressed format and as a result retain a lot of data for a very long time without breaking the banks. Like, hey, this is like the perfect collaboration here. So this is what this project is about. And what I can demonstrate here is some of the data that we're collecting for the Honeynet project from honeypots, and different member chapters are able to use these data. Again, I just want to kind of be very clear here. Hydrolix is not directly profiting from this, so we're not using the data to derive threat intelligence. We are sponsoring the Honeynet project in kind by providing the storage and also paying the bill for compute and storage. So we are just a container, and then different Honeynet project chapters can utilize this data in their research. So, well, let's take a look at what we're seeing here. So actually, this is one of the different tables. We have different honeypots that are collecting data, and they're sending all of the data to Hydrolix. So just to show you, this is actually what a Hydrolix cluster looks like. And here I can look at the dashboard where I can see what utilization we have. And here, obviously, today there has not been much utilization, but it's Friday morning, right? We can also go and look at the data. And here, let's look at the POF table. So POF is one of those passive collection sensors that basically takes everything that's on the wire, everything that's hitting the honeypots, and analyzes that data. And here I can look at this data and I can see, hey, this is the sensor data. This is the entire cluster. And then this is the particular table where we are storing data from this particular honeypot. Now, one thing I can show you here is that we have collected over the last year and a half 678 gigabytes of raw data, and this is compressed to only 30 gigabytes of data. So you can see here we're looking at a factor of compression of 22 times, 22x. So instead of us having to pay for this amount of storage, we're actually only paying for this. And this is one of those cases where it very clearly demonstrates the benefit of the technology. Now, also, one other thing is, since this is a development cluster, I actually am duplicating the data because I'm storing it in different formats, in different ways. So I'm actually duplicating data. Otherwise, the compression here would have been much higher, but I also can run some benchmarks and other tests. And this is why I am using basically having a duplicate of the data. Now,
Awesome.
showing you a little bit more here, you can see there's different additional options that you can see here, but I just want to go and explore the data just to show you what we're dealing with here. So I'll go in the query interface here, and I'll look at the query interface, which is probably the best way to explore the data. And you can see here, if I go to the POF data, I can see what the table looks like. So here we're looking at a data that has fairly good number of columns. We're looking at least 45 to 50 columns here, and those are of different types. You can see date time, string, you can see the source port. Now here, this is an older iteration of the software. This was deployed close to 2 years ago. This is why the IP is stored at string, but currently the Hydrolix engine natively supports IP address. So at some point I'm going to retrofit this as well, but it just hasn't been one of those things very high, on the priority list. But again, you can see there's a lot of different data columns here. Which is to also illustrate how good we are at storing data in storing sparse data. Not all of those columns are completely occupied with data, but again, we're really good at compressing this data and using this space. Now, I was also mentioning something about changing the IP address here from being a string to being a dedicated data type, which again is something that's very interesting about the Hydrolix architecture. Like a regular database, relational database, I am not going to fire up a query that may take 2 or 3 days to retrofit those 700 gigabytes. The way the software works, the next partition that is written is going to have the new schema, and then it is going to start recording the data in an even more compressed way. Instead of using a string for the IP address, it's going to use 4 bytes or for IPv6, 128. So bits. This is kind of interesting as well because the database or the storage engine is very adaptive. And when you delete, add, or change columns, they just appear or disappear from the next partition that is written. And this does not in any way interfere with the ability to query old schemas, just because if a table is deleted, then there'll be just no data for that time period when it was deleted, or when a column is added, it is going to show the data in the time period after the column was added, but there'll be basically no data before that, which is something again fairly unique, I think, for what we are offering. So I mentioned the relational database. So one of the ways we can represent ourselves is also we can look like a SQL database. So here I'm going to show you a query that basically is simple SQL query, and here I'm going to limit, let's say, 200 rows, because I'm using the web interface here to launch an API query. And having more than 100 records being sent to my browser is not going to be very healthy for my computer. Thus, I am going to limit it to 100. But my point here is that first you can see how this thing works, and also everything that our web interface uses is the actual queries that are sent to the engine. And when you're using programming language to directly interface with that engine, that's how it's going to work. So it's not like there's a custom user interface and separate API interface. Everything goes through the API. So there's complete parity with what you can do in this UI and what you can do in the system. And the other thing that's also very beneficial here is that you can very easily test how things will work during your development cycle. So this makes it also very, very easy to develop. And here you can see some of the data, basically what has been recorded in this table. Now, what is a demo without powerful pictures? So this is what I'm going to jump to next. And here I'm going to show you how we are going to visualize the data. Now, many of our people in our audience are going to recognize Grafana. Yes, we're using Grafana as visualization because we are a storage engine. We do not manage how you visualize the data. You can use anything to visualize the data. And in many cases, you can write your own custom front end to manage that data. So don't be confused that you're seeing Grafana here. This is just so that I can demonstrate how the engine works in the background. So here I'm showing you, again, the same POF table. You can see here, that's the POF table. And you can see that we have data here starting since March of 2024. So it's almost going on 2 years, 2 years minus 3 months. But one thing that many people struggle with when they do an investigation is going back in time and querying data for events that have happened long time ago. And this is very important because most advanced persistent threat actors are not going to be very noisy and active. They may have a beacon that only beacons once or twice a month, and then only when there's tasking, there may be a little bit more activity. But if you want to be looking for those beacons, or if you want to look for the initial access when they gain the initial access, this will likely be very long time ago in your logs. I think the average time for detection of an incident was close to a year, and from practice I can tell you that in many cases it's much more for most companies. So if you want to look at when something happened, how it happened in the very beginning, you need to retain a lot of data. You need to have a lot of this data, and many companies unfortunately have to use some kind of a code storage where they are archiving the data. Again, it's very expensive for them, but that what becomes even more expensive is when they conduct an investigation. Because when they do so, the amount of time that the incident response personnel or the personnel that does troubleshooting, if it's not security related, but if it's about some other kind of function, the amount of time they have to spend on restoring data or waiting for queries to return is excessive and decreases their productivity drastically. So here I'm going to show you, I'm going to randomly hop to somewhere in the very beginning here, as far as I can. We're talking about here, year and a half worth of data, year and 9 months worth of data. And I'm just going to zoom in here on a random place. So I'm going to do this. Click 1, 2. Oh, wait, I didn't click. I didn't do anything. Okay, let's do it again. I am selecting, and then I'm going to release the mouse now. 1, 2, 3, 4. Okay, 4. Okay, so it took less than 4 seconds for it to run 2 parallel queries. Because keep in mind, when I did that, when I changed this time window here, the query was run both for this graphic and for this graphic. So in under 4 seconds, I got the results of what I wanted to see. Here you can see I basically have, because of the way it's zoomed, here I have over a week worth of data. As a matter of fact, just getting to the data is going to be sub-second, but just because it had to summarize data for an entire week, it took another couple of seconds for it to catch up. And again, this is doing it over 2 graphs. So this is just a demo how quickly we can access data, and the access of data is pretty much constant time. It always will take about the same amount of time. Here, I'm going to zoom here. There you go. 1, 2, a little over 2 seconds to zoom over here, and did it for both graphs. So you can see this is very fast.
Absolutely.
So this is the appeal of the technology, is raw storage that you can incorporate in security system. You can incorporate this in a SIEM system. You can incorporate this in a traffic accounting system. You can incorporate this in anything you want and write the front end on top of it and use this as an extremely fast storage, which is basically optimized for append operations and for operating within time space. So you always will have this leading timestamp as when the event or when the log line got in the storage. And this is in kind of the somewhat shorter version of what the storage system does and how it is helping people in the Honeynet project do research on the badness on the.
That's awesome. So with that, with all this data being stored in different Honeynet chapters using the same data, are they using it to create like forecasting, or do you have an idea of like what other projects or what other usage they're using all this data for?
I think we should probably have a separate conversation. Maybe we should invite somebody from the Honeynet project board to speak about that, because I do not have a lot of visibility in what other chapters do. But I can tell you that what we do here with our storage is we're allowing all of those chapters to have one unified place where this data is stored versus everybody storing a local copy of the data. And this is the power of this, because it allows every chapter, because those are run on shoestring budgets, right? They don't even have budgets. The one that I'm starting here at Purdue is going to be basically zero budget. It will be a student club where people just spend their time to do interesting work. So there'll be no budget for them to have for storage. And this is where Hydrolix is very, very helpful to the community by providing this unique opportunity to store all this data in one place. And speaking of all this data, this is just one of the tables here. We looked at we looked at the POF table that I showed you. Let's look at the Suricata table. Here we're also talking about 250 million rows, 150 gigabytes of data, again, compressed here to 10 gigabytes. And again, this is actually, 23x compression. So that's kind of the value proposition that we give, to the community. We're allowing them to store all this data in one place. Actually, I can even show you a little more pretty pictures here. So this is the POF data. But if we look at the Suricata data, which is a proper intrusion detection system, and here you can see how actually your SIM can store the data in this storage and then visualize it later. You can see the number of events, IP addresses, GA3 hashes. This is just what it's exporting now. You can see unique events over unique IP addresses that have been observed. You can see distribution by autonomous systems. You can see where the traffic is coming from or by countries. Interesting how Bulgaria made it so far. It's a very small country. India, Russia, big countries, understood. And there you can see the different alerts. So here, there you go, the alerts that are stored. And again, this is like if you're running some kind of an IDS, this is the perfect location to store your data. Just perfect, because you can very easily, very quickly get to the data you're looking for. And again, here in Grafana, we just have summary information. But if you're doing an actual investigation, let's say you have an intrusion from this thing, you can just very quickly go here. And you have noticed something suspicious about this IP address. I go into the data, and then I am going to say, hey, I actually query. And then here I actually want to pick something from Suricata. And I'm going to say, let's say this. I don't remember this. We have some error here. Let's start over. Let's start from scratch. There you go. So there was probably something there that was broken. But let's say we're looking for the IP address, right? So let's see what this thing is named. Destination IP. This is the honeypot address. I need to see the source address. There you go. IP. So this is select IP equals. You know what? I probably have to brush up on my SQL skills here a little bit. There you go. And you can see where this is coming from.
Okay.
And see how quickly it also produced the results. So yeah, that's how this works. I can also download it in JSON. I can download it in CVS. Obviously, when I'm looking at something more targeted, I will probably have even more limited amount of data, and if I want to do any processing. But again, here you can see I'm looking at an RDP event. Somebody was trying to exploit RDP RDP server that was positioned on that particular server. We can see that this particular IP address is a scanner hitting all over the place, looking for RDP servers so that it can test credentials and potentially gain access to those systems.
Awesome. So one of my kind of like last questions is for this, because now they've created an open source community to where you can essentially put in information and code and queries about the latest threats and the latest attacks. How helpful is this to the community as a whole?
I think it is immensely helpful for research. This is just a unique set of data and also has unique time span. So I think this is extremely valuable. Just to actually show you something on the screen, I apologize. Okay. See, you can even see here we have, let's say, the SSH scanner. So those are SSH scanners. You can see, many of them are written in Go. You can see some of them are using libSSH particular version. Another set are using this. You can see a lot of them are coming from different versions of libSSH, but there is also significant amount of Go. And then there are other types of clients. You can see for the HTTP attempts to gain access to those honeypots, you can see what are the different browsers. You can see actually Census. Census is a collection engine that scans the internet and tries to enumerate different assets. You can see actually here, this honeypot obviously has not been hit so much by criminals, but has gotten a good amount of Census attention. But you can see there's also some other stuff. There's a Go client that's hitting it for unknown reason. Now there's also a Mozilla client. Well, why would somebody be hitting this honeypot? The honeypot is completely stale, dead. There's nothing really there. So for somebody to be looking at it, that means that probably somebody is masquerading. And here, obviously, with zgrab, obviously somebody is masquerading here, but they're pretending to be to be a browser. So this is a more advanced scanner, which can help people draw conclusions about the origin of this. So let's see what else I wanted to show you here. Oh yeah, you can see also Palo Alto Networks device has reached to it. So there's all kinds of stuff. You can also see breakdown by different HTTP methods that were used, and also the destination ports, how what was targeted. So there's a lot of interesting information here. And again, those are all summaries. When you start looking at specifics, looking at particular threat actors, there's a lot more that you could potentially discover.
I wonder, in this way, even when you're drilling down and getting all this particular data, is there a way to differentiate between human actors and bot actors?
Technically, you could, but it would have to do there will have to be some post-processing of the data, basically. It will not be directly through this dashboard that I'm showing you here.
Okay.
I mean, some of the stuff is very obvious, like, obviously if it's coming from, from Census, we know that this is a bot, just because we know that. But, this is kind of simple. And, this is a scanner as well. We know it's a bot or a human that executed the scanner. But you need additional information looking at the actual data in order to determine that.
Okay, awesome. Well, you have enlightened me, and I hope the audience with all of this awesome stuff. I hope more people find out and get into and even contribute to the Honeynet project and join any local chapters, any chapters, or support any chapters that they can. In that, do you have any parting words for the folks?
No, I stay healthy, stay focused, and there is a lot of work to be done. And pick up the tools that can empower you to do your work more efficiently so that you can get more done within smaller amount of time.
Right. Thank you so much.
Thank you, Josh. Have a great day.
I know.
Bye.